Okay, now let's look at writing some recursive functions. Now I'm assuming if you're watching this video that you've already tried at least the first problem on your own. And what I recommend you do is that you try a problem before you watch the video for each one of these. However, if you try to write the first one and you're struggling or you got stuck later on, it's fine to watch the video for one of them and then keep moving and trying. But keep trying to test them yourself so that you can really make sure that you've mastered these concepts. Okay, so the first question is to write a recursive function sum in pseudocode that calculates the sum of 1 to n. Now, if you'll notice, we could write this out iteratively, right? Let's look at these elements, and we can watch the transformation from an iterative or loop-based solution to recursive. So we'll do it both ways so you can see. So an iterative one, we might have take a function sum n. We'd have to make a variable for sum, and then for I in, let's say, 1 to n. I love pseudocode. I get to pick whatever I like. Sum plus equals I, and then we're going to return sum. So if you notice the elements of the loop-based solution, we're going to we're going to be adding each time, and we're repeating from 1 to n. This is the base case. Here, let me change colors on that. And then this is going to be the recursive case. And here we really needed what's called an aggregator or accumulator variable. So an aggregator slash an accumulator. I've seen it multiple ways. So sum is this aggregator slash accumulator variable. Okay, we're not going to need that same kind of accumulator variable in recursion because we're just going to take advantage of the call stack and the way that programs execute to do that for us. It's still these values that are going into the accumulator are still stored in memory, but we don't have to explicitly write it out. So in the recursive case, I'll have my function sum. And then first off, I'm going to write my base case. So if n is less than 1, I'm going to return 0. So that's going to be my base case. I'm going to start off with 0. Otherwise, now I don't actually have to write an else here because I'm returning from my if. So I don't need the else. If I wasn't returning from my if, I would need the else. But I like to be simple and efficient. So I'm going to just simply return n plus the sum of n minus 1. So I'm going to start at n and add up all the numbers from n to 1. And then once I get to 0, that's going to be less than 1. I'm going to use the base case. So just to reiterate, this is the base case. And this is the recursive case. Okay. Now, if you haven't tried the next example yet, pause the video, try it, see if you can figure it out, and then come back. In problem 2, we're looking to write a recursive function, sageac, that takes a string as a parameter and returns the number of vowels in the string. So I'm not going to write this particular solution as a loop, but I do want to urge you to consider on the other worksheet, we had some example recursive problems, G, H, F, and C. Part of a good problem solver is finding examples that are similar to what you want to do. Do you see any of these functions that deal with strings and recursively process a string? Well, yes, I do. So that's the process I'm going to be following. Okay, so I'm going to write a function sageac that takes a string. I'm going to say it takes a string s. And it's going to return the number of vowels in the string. Okay, so I'm going to use the same thing I did before. I'm going to create a variable x. I'm going to initialize it to 0. If s of 0 let's see, is val. I'm going to simply write this out. There's a lot of different ways that you could write this. Here, I'll say this is more common. Is val S sub 0. And as long as it's clear and two different programmers who read your pseudocode statement and would implement the same thing, it would get the same result, it's totally fine. So if S0 is a val, then I'm going to say x equals 1. And I also need a base case. I didn't do my base case yet. So somewhere, I probably should have done this before that. Let's see if I can move this. So let me see. Here we go. Let's make a little room. All right. I moved it. The magic of computers. Okay, if the length of S is 0, I'm going to return 0. Excuse me. So if my string doesn't have any length, I'm going to be returning 0. I want to do this before I check to see if S of 0 is val, because this assumes the length of our string is greater than 0. So I want to make sure I do this first or I'll get an error. Okay. After I've checked to see if the val is there, then I'm simply going to return x plus say jack on S of 1 to the end. And so this is shorthand. I'm doing 1 colon. That's shorthand in Python for starting at index 1 and going up through and to the end. And so that's the shorthand I use all the time. Okay, so the first step, we've got 2 base cases here, right? And well, no, we have 1 base case. Just 1. But this is the base case. And then we have 2 recursive steps. This is the recursive case. So I'm checking to see if it's a val, and if it's a val, then I'm adding 1 to it. Otherwise, I'm adding 0 to it. And that's it. So once you get the hang of this, I know it can be tricky to wrap your head around. It's a new challenge, new perspective for thinking through problems. But once you do, it is really straightforward. And I have to admit, when I first started teaching recursion and teaching these string and sequence-based problems, I definitely had to think about it, right? I had to sit down, write it out before going into class. Now I can kind of do it off the cuff, and it's easy. And so it gets easier with time. It just takes practice. All right, let's look at the final one, Fibonacci. Fibonacci is going to sum the previous 2 numbers in the sequence. And assuming the first 2 numbers in the sequence are 0 and 1. So let's do a function. Fibonacci takes the number n, let's say. All right, and so this is going to have 2 base cases because the first 2 numbers of the sequence are 0 or 1. So if n is 0 or n equals 1, I'm going to simply return n. Now, I am assuming that n is greater than or equal to 0. Now, you could change that. You could add another base case if n is less than 0, right? You could just say if n less than 0, you could still return 0, right, if you wanted to. I'm choosing not to do that here. All right. So otherwise, what am I going to do? I am going to return the sum of Fibonacci of n minus 1 plus the Fibonacci of n minus 2. So any Fibonacci number is summing the previous 2 values together. Now this example isn't super efficient because I'm calculating every number twice. It's going to take a long time to run, but it's not efficient to run, but it's efficient to write, and it's very, very concise. And so now you're ready to try and tackle writing even more recursive problems.